I was here this year to work with the adaptive structural skin cluster. The idea of the cluster was to be able to create foldable adaptive skins that started out as flat elements and then folded up into complex multi-curvature forms. And I used generative components and a plugin called Kangaroo to be able to model and simulate the flat shape, the curved shape, and all of the kind of in-between iterations of how would this structure actually deploy. And more importantly, when we get the complex curvature in the structure, can we actually fold it back to flat? That was the kind of goal of the structure. It was all done inside the software. After that initial paper model test, every drop of analyzation, testing, modeling, performance, it was all done within the software itself. The tools allowed us to be able to say, well, if this really is the shape we want, this is where we're going to have to start to put tension and compression members. This is where we're going to have to start to add connectivity. This is where we're going to have to start to add stiffness or a kink in the system to allow it to not bend back and to be able to stabilize it. The unique part about generative components is its ability to run native geometry. I'm able to section it, render it, cut it, put it on sheets, and more importantly, link it into other packages that I'm using without having to do a lot of jumping through hoops. In terms of using it for actual construction and constructability, that to me is one of its best features, is its ability to work with native geometry that's there. GC contributed to my cluster's objective in that without the ability to have simulated the system, it really just wouldn't have been possible.